Well, my name is Gemma. I work in the VUA Innovation Center in Madrid, Spain. Today, I'm going to complement Michaela's talk about TensorFlow. And we are going to talk about 3 cases of use using this machine learning library. At first, I will do a classification problem comparing scikit-learn code into Tensor. After that, we will dig into the NASA Space Apps Challenge hackathon that I won this year, doing a program with for classification of an impact prediction for asteroids. And after that, I will dig into a Limbic system reverse engineer brain project that I'm working on. So how many of you are actually working with a machine learning library, or ever has? Okay, nice. So for this introduction, I'm just going to talk about this code comparator to see how easy it is to make like any kind of classification problem using scikit-learn and the API of TensorFlow. For that, I will use the Titanic dataset, trying to classify how is your probability to die or to sink, depending on the data of the passengers, okay? So, amazing topic. For that, I have like choosing for the data, the survived, age, and fair class in the dataset. Why? Because when the Titanic sank, people will say like, okay, let's save first the child and woman or man, and after they were looking after the fare or the amount of money that the passenger were paying for the Titanic embark side. So for that, at first, I will like comparing code for the scikit-learn. I'm using pandas for importing like the data, and then I'm going to use like the linear logistic regression model, and I'm also going to load like the metrics that scikit-learn can give us about the classification. I'm putting like the data, splitting the training and the test data, because this is very important in machine learning. We have like a data set, and then we test the data, and we say, okay, from this side, you're going to learn from the training data, and the test, you're going to test if this data is good or is not. So at the end, I just split it with a side and a random state. At the end, doing like this logistic regression with scikit-learn is no longer than one line of code, okay? Like taking like this fitting for the training, and we print the accuracy, how well this model of classifying is doing. As you can see here, we have like a 0.67. This is the first approach of scikit-learn. As Michaela told in the previous talk, if you remember the kitchen classifier, we had like an 0.49 accuracy score. So we should like also like be some kind of exactive and compare how well new libraries of machine learning are doing in compare with TensorFlow. With TensorFlow, what I'm going to do, I'm going to import the learn layer, but I'm also to import the metrics, because in this approach, TensorFlow is very like focused on graphs, as Michaela said, and in this experiment, I wanted to put like only the accuracy to test it. So here, as you can see, we also like test split into the training and test data. But here we use the linear classifier that Michaela has also like done before. And we do the optimizer. In the optimizer, we use like the learning rate, that it means how many times we are going to tell the network to learn from something, okay? So here we fit it, and we change the steps, the training steps, and the batch size. That means that I'm going to put the data of training, and tell like 1,000 steps. Okay, learn from this, learn from this, learn from this. So at the end, there is like computation in between the steps and the learning rate that gave us like the accuracy. So in this first experiment, the conclusion was that, okay, from the first approach, scikit-learn gave us like more accuracy. But when I was able to really fit the TensorFlow model, it works better. Now I'm going to talk about architecture, how important it is to seize the data and to give the data a meaning. Deep learning is not a magic box in which you can pull all your columns around and gives you a result. The data has to be ordered and has to have a meaning. A few months ago, NASA released their main core problems that they are trying to solve once a year and made that like open for innovators all over the world. One of the main challenges they've got was to prevent or make a program that could predict and classify NEOs, near orbital objects around the solar system cycle, and how if they can be like a problem. This classification problem, this problem is very human. They have to be like observing all time the asteroids or the NEOs. So I'm going to tell you more or less how it works. They at first are in an observatory or wherever, and they see something, okay? Then they classify it based on several points that they see, like the velocity, the color, etc. And then they wait for a while, and then they observe that asteroid through the time. So the problem here was, how can we do something with machine learning? How can we train a method that really like gave us like out all this human work? So we developed this project that was called Deep Asteroid. That more or less was an architectural neural network that could like help us to classify. We gather like 6 technology geeks that we basically were passionate about the potential of machine learning, and we believe deeply in the power of producing knowledge through data. We knew we have like this problem of measuring the odds, and we wanted to predict, but we also wanted to classify how this could work. So at the end, we went to Open NASA. That is a huge platform that gets a lot of data that you can like dive in, and we selected like the most like significant data sets that could help us to deal with this problem. One of those was the potential hazardous asteroids dataset. That means like they have like all the NEO that were like less than 0.05 astronomical units, because that's the odd that the asteroid has to impact on Earth once it is those near. And also like the moids. That is like the minimum orbit intersection distance that we could have like with the Earth and the NEO. We, as you know, at the end, like a neuron is no more than an input and an output, and we use like several kind of functions to try to seize and give that neuron a meaning. So what we use is, okay, let's use like trigonometric function and wave functions, because that's the kind of orbit or trajectory that an asteroid can have. And at the end, we are teaching that neuron how the asteroid was moving. So as Mihailak has told, there is a hierarchy here when you're doing a neural net. And we were like studying a lot with mathematicians and experts of the field. How was this going to work? So at the first layer, we were with this potential hazardous asteroids data. And then they gave us like a classification that was like the Aten and Apollo asteroids. Those are the ones that we want to study because are the potentially dangerous to impact on Earth. But as I told you before, astronomic astronomic field and astronomic asteroids work a lot with time. If you wait time and then you classify again the asteroid, it might change. So it was important for the neural net to know. Then we would created another layer that was talking about how the time could impact in the asteroid classification. At the end, we also like use the Tholen class. So for you to know, it starts with physics. Okay, this is the physics data. Then we have like the classification with the human knowledge, and then we have like the more chemist kind of classification, because also when the asteroids come nearby, you can see more things about it, like the color. So this is like the hierarchy for classification that we put into the neural net. At the end, okay, like TensorFlow wants to say to you that doing a neural net is easy, and they have like put very straightforward path, and that's okay. But you have to also have like some kind of a craftsmanship process. So if I were you and I say, okay, I want to design a neural net about wherever, kittens, asteroids, dogs, wherever, at first I would tell to you that really like study the data sets and find the data set that go from the general knowledge to the most accurate or small knowledge. If I want to classify cats, for example, or kittens, at the first layer, I put like pictures of a kitten with the tail and the 4 legs, okay? And then I go up, and then maybe I put only the face of a kitten. And then I go up again, and then I put only like the hair of a kitten. So if I saw a picture of a kitten, and there's like a kittens on a cage, okay? As I have been training all along the neural net, you can really recognize it. This is very important because if you don't know that, and only train like image of a kitten with a tail and 4 legs, then you give a face of a kitten and say, this is not a kitten. I don't see like a tail. So this is important to seize the data, to give the data a meaning when you're training a neural net. You also have a lot of protocols. In this case, we have like the neo-recognizing protocol that was already a book that allow us to prune a lot of data and be aware of taking off a lot of data. This is also very important when training a neural net, because if not, you're like putting a lot of noise. Okay, this is a hierarchy state of training. At the end, this is key, because if not, you could be doing all lot long. Be aware of that the layers have to be evaluated each time you make a layer, okay, just pruning. In fact, TensorFlow, it's very good for that, because you can slice the tensor that are one of the main core units, and then put like second, third, 4 layer, wherever you might want. At the end, we were awarded. We were in between among the 25 best projects around the world in the first 5 for best use of data. So at the end, like NASA called us and say, okay, guys, this is great because you are like really, really, really getting knowledge into a net, not just like seizing a model and pruning and giving all the data. And I'm going to talk about what I believe is the future of TensorFlow. That is more like the reverse engineer path. For that, I will pass among was a real story that happened to me, and how I deal with that. So a few months ago, I appeared a troll on the internet in my Twitter account. It was like really smashing for me and a really, really, really hard time. And I started to think about the awareness of the internet and what is that digital world imploding over the human emotions. But I also was like digging into it, and I get into the Ghostbusters actress case, in which she was like smashed on Twitter, and suddenly I realized that I was not alone, and that we were like implementing hate with big data, with data over the internet, and what could we really do with that? So I started to think about how can I do a solution that really like help me to deal with that, using maybe like cybersecurity tools, but also like artificial intelligence to transform that reality and to create something new. So then I started to work with a neural net that could help me like to identify those trolls, to see what was happening like on the internet with hate, and how could I do something about it. And then I realized that how I size the data was very important. So I took like Plutnik basic 5 emotion classification, okay? Philosophy is like dealing with this during 2,000 years, and I'm just taking like what I believe there are high quality models and implement them into programming language, okay? So when you talk about hate is an emotion that doesn't come along. At first, hate comes in a sense of abhorrence, of a boring state, and it can be like even transformed into rage. So I created like with a weight vector thoughts of words, what I believe was like this cluster of how this emotion was working from the low level, okay, that was like those abhorrence, to the high level rage. And then I created like this tensor on TensorFlow. We've had like that maximum gradient of emotion. What I can say of this, okay, if I'm seeing like input abhorrence, that means that person, I'm weighting his or her words on Twitter, and then I get a weight into their abhorrence, their hate, or their rage. Here is the mathematical model Michaela told you about, that sees for the classification. As she told you, we were creating the variables without weights and bias, and we will also like have that three-dimensional tensor for having like the points of information. This is like obvious when you're doing a classification model. And this is what with Michaela told you about this multiplication in between the bias, and we zoom like the input. But neural nets are complex, and things are not linear. So at the end, like the first grade of complexity that you can like give to a neural network is making like convolutional. Okay, so having like this, the model that Michaela has told you about this linear function that draws a line, you can like apply the sigmoid function that what does is like it transforms the line into an exponential neural net pattern. So from this, just only with this line of code, you transform a line into a neuron classification. Also, the placeholder, that is this architect, this space that I'm giving the given. On the cross entropy, like Michaela didn't talk about this so much, but I think this is like very important because it tells you like how well the neural net is doing, how well it's learning. And this is a mathematical function that has like this aim to be. At the end, it's very important, as she said, like the training steps and how we optimize it. We start the session because, as you know, like we are always like competing graphs, and we correct the predictions with the evaluation has 2 steps that are like quite important. We correct the neuron, and we see like the accuracy that it has. That's why I don't believe like deep learning is a magic black box in which you put everything and you get like results. You have to be like seasoned at first. I would say like, okay, take like data that you know and the result you might know it as well, okay? So there you correct the predictions and the accuracy that you get. So then you can scale it and put a lot of data. So make it like small first and then let's scale up. But at the end, an emotion is not only that. It's not like a state that I can, like, it's not a picture. Emotions are things that are moving on and have like their complexity. And I was like thinking, how could I extract that emotion better and try to really, really understand the troll and not only like make the picture of the troll in a several time and try to understand better to change in a more accurate and better way. So I was thinking a lot about maths because artificial intelligence had really a lot of maths on it. And I was thinking about the imaginary numbers. Imaginary numbers are great because they are like abstract things that doesn't exist, but when you combine it together, they provide real things or scalar values. So at the end, like I was thinking, like emotions could also like work as the imaginary numbers because we have like our emotions are like all around us, and at the end, like it drives us to an action that we can measure. So also I was thinking that emotion has a gradient itself. Before you've got an emotion, you kind of feel something. You have like there, but even before you feel it, you have like some kind of sensation. So at this time, you could see, okay, I have this emotion, but before being an emotion or before being strong enough for me to say something, it might be some kind of sensation that I could not even print on the internet. So I could do a model in which I can see some trolls that actually are not trolls yet. So I created like this kind of tensor, having like the gradient of an emotion, but also the emotion itself. So at the end, I have like this matrix in which I can put like how this emotion like was working at a very complex level. So at the end, it was great because I was like thinking about how numbers like well talking to themselves and like P telling to the okay guy like be rational. You cannot be like that. And the imaginary number like okay like get real. Don't be like that. So at the end, it's like it's a maths conversation in between numbers that you can associate to problems, to complex problems. So, okay, this gets better in Python because I can like put like this library. Also, like I can like make this tuple in which I can put the complex numbers, and I can read also my trolls data set, and I can like start like making like those tensors again that have like that complex part. This complex part, okay, I don't know if you have like been working a lot with TensorFlow, but at the end, one of the things that I love about this is that you can like size also the type of tensor that you can have. So for example, if you're working with images, you are going to use IT32. In this case, as I was working with a complex number, with a scalar, I was using like this kind of tensor. So what we were doing was like we were creating a neural net that was giving us service, okay? So this is, I think this is the core future of artificial intelligence now. And you as programmers can create what I call like a neural net as a service that go like beyond the software as a service. And you can like solve a problem using this. I don't know if Michaela has told you about this, but if you are new to TensorFlow or would like to get into machine learning, I recommend you like this Tensorflow Playground.org, that it gives you like very visually with these neurons, hidden layers, the layers of the cake that we are putting, the relationship of the data, and the kind of problem that you want to solve. It gives you like an approach to how the problem is going to be heading with. This is very useful, and I always, when I think about a neural net, even before starting to code, I go here and I see more or less the classification and see, okay, this has like a meaning, or it is coherent. So if you guys would like to go into neural nets, I really recommend this website. And here I put what is a neural net in terms of code, because okay, you have seen like arrows, data, but how can I code a neural net? I define the neural net, and then the most important thing that you're going to be dealing with and changing are the hidden units, which Michaela has told you about. Also, the activation function we have seen in the asteroid exercise, how we are dealing with that, how we're ceasing like the functions, and the regressions that we are going to have, like kind of the final classification problems that they are going to solve. Also, the things like the learning rate. So at the end, okay, you have like the target, logics. The logic is the problem and the layers of a cake and the function that I'm going to have, the logistic that I'm going to put, and the learning rate. And then I started thinking again after this and say, okay, so emotions are complex, more complex even than that, because we are like heading the internet. The internet is flowing data all the time and is changing, and artificial intelligence should be more like a picture of a problem, and at the end, like a brain is it's a neural net of the neural nets. What I mean is that we connect neural nets and we create brains. Okay, so at the end, I think this is the problem that artificial intelligence wants to really, really solve. Okay, so as I was heading with and actually I'm heading with my dear troll, I was thinking that at the end, I wanted to have like a negative emotion, and I didn't want like accuracy level of trolling or wherever. I want to infer a real emotion on this troll. I want to change. I want to give feedback and transform that negative tweet or negative bird that is common into a positive one. So limbic system is a part of the brain that is like beyond the neocortex, okay? That basically it deals with our emotional selves. The neocortex drives for general intelligence, where it's like memory and processing, but limbic system is different. It deals with our strength for or avoiding danger, with dealing with our emotions. So at the end, it's a part of a brain that is like processing that. So I started to think how and draw and be aware of how brains really work, and how this part of the brain at the end is like influencing the neocortex and driving us into that emotion rationalization. And at the end, we have like a structure that we could like impair or try to do a reverse engineer of that. So at the end, it has like 4 main core parts, okay? And different kind of inputs. We have the thalamus, sensory cortex. For the sensory cortex, we have the orbitofrontal and amygdala. And then we have 2 kind of different inputs that come here, okay? What we call sensory inputs, I mean images. We deal a lot of images in our emotional brain, but also emotional signals that are interpreted, that are like my mathematical models. So, okay, it's great because I take like the inception already, like all training neural net of Google that has with tons of images, and I plug it to my emotional mathematical model, creating more complex data sets to deal with that. For this, you can say, okay, so what is the input? I have like images, I have an emotional signal, and then I have a box that you know, guys, that is no longer a box. And then I have like an output that is going to be another tweet. This tweet is going to have an emotional gradient that goes from the being assertive, okay, you're trolling me, but I'm going to put you an assertive tweet, to compassion, because at the end, like haters are like unsolved souls that have something to say, and we shouldn't like just keep hate apart. We should listen, and we should also like show some compassion about this. And now I'm dealing with the next challenge for this, that is getting the data that I really need, because I have like the Inception model data sets in which I have like pictures of trains or kittens or dogs, but I need pictures of joy. I need pictures of being sad. I need pictures of hate. So the data set that I need is like quite specific for this, and it has to be huge. So I'm working every day on building this. But I also need like tons of that verbal kind of data that is giving me like those emotional signals. So I hope to one day like finish my emotional brain. In the meantime, if you have the opportunity to get with a troll as I did, please forgive. But also stay calm, okay? And if it really hurts you, stay just away from the phone. Because at the end, like the data always flows, especially with trigonometric transfer function. Thank you.
Do you already open source your findings?
Sorry?
Did you open source your project?
Yeah, you can find it on my GitHub, GitHub-SOI-Gemma-Limbic system. So if you want to pull request me or whatever, it's the GitHub and that's this user.
Hi, sorry, maybe to get it easier, maybe can you share it on Twitter with the hashtag DFCH16?
Sorry?
Just to share your repo, your GitHub repo, can you put it on Twitter with the hashtag DFCH16? Or DevFest?
Yes.
After, not now, but after, then people can just go on Twitter and get it. No pressure. No, it's okay.
So I don't know if you guys are like working or would like to work in a project using like this. If you want to ask me like some questions about that, or if you're like developing something.
Thanks for the presentation. My question is, you have images and you perceive images differently than another person because you have emotional experience with these images. So how do you classify an image to an emotion?
Yeah. For that, I would recommend you to go. I have used like the API that Cloud Machine Google has used for the Cloud Machine vision. It like really classifies you like faces of people, for example, based on smiles and on the eye like habit, and then I get like very like subjective, like with people, things that I consider like joy. For example, I put like landscapes that are like calm or joyful into it. So at the end, it has like a very craftsman design method. But for the emotion, for example, for joy and sad, I use mostly faces and also colors, because you can use like the colors of joy or colors of sad. So I research on the internet, which is like the overall design tips for emotion. And also, for example, you can use a lot of emoticons for that. Blutnik instead has like a conic overview of how an emoticon can like redirect to a kind of emotion. So emoticon has done a lot for emotion recognition, actually. Especially on Twitter, because in Twitter, people put a lot of emoticons.
There's the next one. I'm coming.
Hi, very interesting. I have a question regarding your first use case, because you compare a scikit with TensorFlow, but have you compared other frameworks? And maybe you can explain shortly what are the advantages of ones over the others?
Okay, I have tried Teano and Café also. And PyBrain, there is like a research library resource for German university. I think TensorFlow with that is doing an amazing job with getting all the problems of neural net design and create an architecture that can like gives you like more design approach method. I think the value proposition of TensorFlow is that in each layer you can seize the data and you can like rearrange like the tensors and how well it's like doing. I think one of the guys over there in the previous talk, they asked like, okay, like human learn from mistakes. So neural nets also learn their mistakes. And we need to be able to detect that, to slice it, and to redirect the tensors to go in a previous way. And that is a thing that in Tiano and Café is very messy, okay, to software, to doing on software, but with Tensor it's like very good. I also have tried like the Gym from OpenAI, and it's doing like a quite good job too. But the Gym, the thing that it has is like their core are focused on strategic kind of solving. That's why they are playing video games all the time, because they want to solve that strategic learning, and they want to know why, and that's why I think the Gym is going there. But if I had to focus on that, I would focus on Gym and Tensor. But also it depends a lot on the kind of problem that you want to solve.
Thanks again for the presentation, and also I wanted to ask you what is the goal of your project? Would you like to detect trolling behaviors, to maybe present an API to prevent the trolling from happening itself? Or would you like to take it a step further and also identify the solutions for the troll, like to make a machine psychoanalyst?
Yeah. I'm actually thinking a lot about which kind of product I should make about this. I think one of the main core options I have for this is a bot, make on Twitter, that it responds the trolls. Because when you are a troll and you respond to your troll, it can even be worse. Okay, even showing compassion to your enemy or your troll, not enemy. Can be counterproductive for you. So at the end, it has to be like an overall third party or third person, and that's the cool thing about Twitter, that it's like a lot of people can hear where it's happening. That could make into it. I don't believe that researching like the classification main core troll classification could be totally beneficial, because it can be used for other things. If I make a tool that only detects hate, it can be like it can be also like not dangerous, but it can be like counterproductive for my troll, because I don't want to do that to my troll. I want to help my troll to rehab and become a better troll, more assertive troll, if you can say. So yeah, I believe that the power is there. but I would like to think also more about that. So, but thanks for asking anyway. The future is there also.